Okay, so from last time you learned how to change one number from base 10 into another number in base 2. So now the question is, how can we verify these numbers? How can we verify that we got the correct number in our conversion process? So now I guess the key here is how do we go from base 2 back to base 10 so we can see that we can verify it. So to start off this process, I need to explain a little bit about how the decimal system works. We all understand this intuitively, but it doesn't hurt to have a refresher. So let's take just any number, 985 now, and that's in base 10, and we want to understand exactly what's going on here. Let's sort of peek under the hood of this number, and we'll see that, so if I write this number like this, so 900 plus 80 plus 5 will equal 985, right? I know this looks pretty obvious, but it's necessary to understand exactly what's going on in other number systems, and we can see that now we can go a step further and say, let's take out this 9, let's take out this 5 or this 8, and let's take out the 5. So by that I mean let's think about it like this. So 9 times 100 will give us 900. 8 times 10 will give us 80. And 5 times 1 will give us 5, right? So now this still equals 985. But we can go a step further. This is the beauty of math, and this is why this is so fascinating. I'm always in awe of any of this. But anyway, we can go a step further and we can say now 100 can be even further reduced into a power. So 10 squared is 100 times 9, right? Plus 8 times 10 to the first power, plus 5 times 10 to the 0 power. And that still equals 985. So now the key to understanding here is to know that now you can see that this is our base. Let me highlight this for you. So this is our base, and this remains the same no matter where we are. So you can see in here, this base is still 10 everywhere in this number. The only thing that changes is the exponent that we raised the 10 to. So here you can see it goes from 0 and it increments by 1 all the way up. And now essentially we're doing the same thing in any other number system. You're doing the same thing. All you're doing is changing this base. That's why it's a base. It's you have so that's the if you have, say, x to the y, your x here is the base and your y is the exponent. So now our base is base 10, and here is our exponent, which is the place that it's in. So we call this the ones place because you're multiplying by 1. This is the tens place because this is times 10, and this is the hundreds place because you're multiplying by 100. But like we've just seen, we can replace this with a base to a power. And so it's essentially the same for any other number system. So we ended last time, I believe, on base 11, or 11 in base 2. So 11 in base 2 was 1, 0, 1, 1 in base 2, sorry. And now we go, in order to convert this to base 10, we say, okay, 1 times our base, which is 2, plus 0 times our base, which is 2. And you go through this process multiple times, and you might even already be seeing it. And so now our next number is 1 times our base, which is 2, plus 1, which is our final number, our least significant bit, times our base, which again is 2. And like I said, you noticed from last time what I was just mentioning about how the base never changes. The only thing that changes is our exponent. So now all we have to do is write our exponent. So we start at 0 and we just go up, incrementing by 1. So 0, 1, 2, and 3. So now what does this equal? What number does this equal? So let's think about this for a second. So 2 to the third. See, I already know these answers, but if you want, you can pull out a calculator. You can multiply it by hand, whatever you want to do. So 2 to the third is just 2 times 2 times 2. So now we can say 1 times all of that. So 2 times 2 is 4, and 4 times 2 is 8. So now we have 8. And 1 times 8 is just 8. So now we say 8 plus, so we have 2 times 2, which is 2 squared, is just 4, right? So we have 0 times 4, which is 0, right? And then we have plus, and then you say 2 to the first power is just 2, so 1 times 2 is 2. So we have 8 plus 0 plus 2, and we're almost finished. And then we have, in the final spot, we have 1 times 2 to the 0, which is anything to the 0th power is just 1. So 1 times 1 is 1. And so now our final answer is 8 plus 0 plus 2 plus 1. So let's see, 8 plus 3 equals 11, right? So this is our final answer, and we just learned exactly how to convert from base 10 to base 2, and now from 2 back to 10. And the interesting thing here is you can convert any base number to any other base number. The only trick here is that you have to go through base 10 first. So if I start with a number and say base 8, so I have 7 base 8, and I want to go to some number in base 3, I first have to go from base 8 to some number in base 10, and then from base 10 to some number in base 3. And we've already seen how to do this. And we've seen how to go from, so now we can go from whatever number into base 10, and then from base 10 into whatever other base that we want to go to. And it's all the same. It's all the same process. You just are replacing your number. So if we're converting from base 10 to another base, we replace the number that we're dividing by with the base. So in this case, it would be 3. So instead of dividing a number by 2, we divide now by 3. And that process is the same. So now what we want to do is that's sort of the end of how we convert from one to the other. It's all essentially the same, and you can play around with it and you can try to understand it. And I highly encourage you to experiment a little bit. Just give yourself a number and try to go from that base to another base. And also remember that if you're in base, say your base is 8, this is just something about number systems in general, is that a number system can never be higher than its base. So like the numbers that make up base 8 go from 0 all the way to 7, and then when we add 1 to 7 in base 8, it rolls to the next one. So then you end up with 1, 0 in base 8. So this is actually in the decimal system, this is actually 8. There is no symbol for the number 8 in base 8, and so which is exactly the same for base 3. So the number set that you're working with in base 3 is from 0, 1, 2, and 2. And in base 2, your number set is 0 and 1. So it's always 1 less than your base that you're in. And so you can't, something like 9 in base 8, just it doesn't make any sense. You can't do that. So that's really the only caveat to sort of playing around with this on your own. is you just have to remember that whatever number you have, it can't be higher or equal to your base.